everybody, hopefully everyone can hear the sound in this video, or they're reading this sign and trying to get the sound up and working. This is the just an extra practice skill before we start Chapter 7 in geometry. We've practiced this skill before earlier in the year, but this is just another review of how to simplify radicals. The first thing you need to know is that there are these special numbers that are squares of other numbers, like 4, 9, 16, 25, 36, and so on. So the first thing I'm going to do is I'm going to create a little table for myself with several of these numbers. So if I'm writing too fast, you can always wait until I'm done with my table and then pause the video and write it all down. Now I'm going pretty high. I'm going up to the square root of 225, which is 15. It's highly unlikely that you need all of these, but I just like to have a list that usually goes up to 15. So, like I said, pause the video. As you can see, I'm writing this on the inside cover of my note-taking guide if you need to write all of these down. Okay, so over here, what we want to do is we want to factor. Factoring is breaking a number down, like the number 80, into two numbers that multiply to be 80, like 8 times 10. But, unfortunately, 8 times 10 is not going to be the two factors we're going to use, because we have to actually limit one of our numbers to one of these root values. 4, 9, 16, 25, 36. Do any of these numbers divide evenly into 80? Or, in other words, are one of those numbers, the square root number values, a factor of 80? Well, does 36 divide evenly into 80? No. Does 25 divide evenly into 80? No. How about 16? Does 16 divide evenly into 80? Yes. So since that's the largest number that's a factor of 80, that's the one I'm going to use. 16 goes into 85 times. So 16 and 5 are factors of 80, or a factor pair, as I like to call them. And so, the reason why it was important to choose from this list over here of radical values is so that at least one of these factors is simplifiable. The square root of 16 we can simplify to be just simply 4. Square root of 5 we cannot simplify any further, so we just copy that down. And that is our answer. Now, some of these are a little bigger, and it may take you more time to factor them into two radicals, like 117. So what I would do is I would take my calculator and I would just maybe start with the first number lower than 117, which is 100. 100 doesn't go into 117 evenly, so I'd go 117 divided by 100, enter. And if I don't get a whole number, I keep moving on. Does 81 divide evenly into 117? No. Does 64? No. And so on. I would just keep getting smaller until I found one that worked. And it turns out that 9 is the biggest factor of 117. So I'm going to write 117 as a product of two radicals. So square root of 117 is the same as the square root of 9 times the square root of 13, because 9 times 13 is 117. Notice on the first line here, when I break apart the factors, I take my parent radical and I break it into two smaller value radicals. Both of these on your first line are going to be square root values. Okay? Some people make the mistake of writing one of them as a whole number right away, which is wrong. Once you have your two radical values that you pulled apart from the parent radical, then you can go ahead and simplify the one that you pulled from this list. The square root of 9 is 3. And then the other one is if you've done it correctly, is not simplifiable. Sometimes what happens is we choose a value over here that's not big enough, and then it turns out this other radical we can keep simplifying further. But if you do it correctly, if you start with the biggest radical smaller than the one that you've got, and you just keep getting smaller and smaller until you find one that works, that'll work every time. So if you're feeling confident, you might want to pause the video at this point and just try a few of these on your own, and then start it back up again and see if you got it right. The square root of 288 is divisible by 144, root 144. So you could break this into the square root of 144 times the square root of 2. And the square root of 144 is just plain old 12. The square root of 2 cannot be simplified. And there you go. Now, some people make the mistake here of choosing a value that's not big enough. So they don't use the square root of 144, for example, because, hey, I know that, like 36 divides evenly into 288. So just be really careful with that. If you do that, for example, if you say, oh, the square root of 288 is divisible by square root of 36, because 36 times 8 is 288, you can do it this way, but you have to be really, really careful. The square root of 36 is 6, but the square root of 8, because you didn't actually choose the largest root value from this list over here, that means that this value here, the square root of 8, you can actually keep going with this, meaning that you can factor this. The square root of 8 is factorable into the square root of 4 times the square root of 2. And the square root of 4 is just regular old 2. So you've got 6 times 2 times, and then the square root of 2, you leave it the same. And it gets you to the same answer because 6 times 2 is 12, as you can see. It just took you a little longer because you didn't choose the biggest root factor that of root 288 from the list. So I'm going to show you my solutions for 4, 5, and 6. As you can see for these three, I just made some more examples on the bottom of the page. I'm going to cover those up. As you can see on this one, I did it the fastest way. I chose the largest root factor from the list of the radical 675, square root 675, which is 225, and I came up with my answer immediately because the square root of 3 cannot be factored any further. But some people see 675 and they go, ooh, that's divisible by 25, so they choose this one from the list, not realizing that there's a better, larger value factored there. And then you have to be smart enough to realize that the square root of 27 is actually factorable further. And you could break that down into root 9 times root 3, which gives you 3 root 3, and then you just multiply the like terms together. 5 times 3 is 15, and you do get the same answer. And here's some more examples, 5 and 6, of how I would break those down.